Hello everyone. So previously we had discussed on the topic rod cutting algorithm or the problem, right? So one of the famous DP algorithms or the problem, right? So that uses the mostly it's kind of uses this one unbounded knapsack, right? So this is fine. Today, sorry. Today let's go with the bell numbers as well as the Catalan numbers algorithm. Yeah. So now let's get into the definition part, man. Bell numbers, what it does actually, bell numbers represent the number of ways to partition a set, right? So suppose there exists a set actually. Bell numbers just represents the number of ways to partition a set of n elements into the non-empty subsets. So set of n elements into the non-empty subsets. This you have to remember at any cost, right? So this is what the bell numbers do. Bell numbers represent the number of ways to partition a set of n elements into the non-empty subsets. Then what does the Catalan numbers do? Catalan numbers count the number of ways to correctly match the parenthesis. To correctly match the parenthesis, binary tree structure or non-crossing partitions or non-crossing partitions. Catalan numbers count the number of ways to correctly match the parenthesis, binary tree structures or non-crossing partitions, right? So this is it for the bell and the Catalan numbers definition. Now let's get into the explanation part, man. First, let's go with the bell numbers. Bell numbers is represented by the Bn, right? So just give me a second here. 1 second. Uh, 1 second. Yeah. Bell numbers is represented by Bn actually, right? So this is fine. For example, suppose n is 3 here. So we have considered here B3. B3 equals 5. See, because 1, 2, 3 can be partitioned as, so this one set, this 1, 2, 3, the numbers present in the set 1, 2, 3 can be partitioned as 1, 2, 3, one thing. We are considering all the numbers. This is fine. We can partition 1, 2, so these two numbers, first two numbers at first and the last number, this as different. 1, 2, and 3. So this is also fine. We can just consider first and the third number and the second number as the individual number 1, 3, 2. And we can just consider second and the third number at once and the first number individually. That is also possible. 2, 3, 1. Finally, all the numbers individually 1, 2, and 3. Yeah. So total there are 5 partition here. Total there are 5 partitions. So B3 we have considered that is equivalent to 5 because 1, 2, 3. These 1, 2, 3 can be partitioned as this one. Whatever I have shown here. So this one I found it very useful. So I just wanted to show you guys, right? The example part. So this is fine. So here they can be computed using bell triangle or the dynamic programming. So this one partitions, it can be computed using the bell triangle or the dynamic programming, right? So usually, so as this is DP, this one DP related. So let's go with the dynamic programming, not the bell triangle, right? So this one we can just go with a bell n plus 1 comma 0 equals bell of n comma n, and bell of n plus 1 comma k we can just go with bell of n comma k minus 1 plus bell of n comma k, right? So just try to remember this one. So you'll get to know certain things when we write the code or the algo as well, right? So this is fine. So we are done with the this one bell numbers. Now let's move on with the Catalan numbers as well. Catalan numbers are also represented by basically Cn, similarly to the bell numbers Pn. So this is nothing but the Catalan numbers Cn, right? So they appear in combinator X. So this is very important. So usually Catalan numbers, what where do they appear actually? They appear on combinator X involving the recursive structures, right? Involving the recursive structures, right? So number of valid parenthesis expressions as well, right? So they appear in combinator X involving recursive structure. Also, number of valid parenthesis expressions. This is also fine, and also number of full binary trees. So this is third one, and the fourth one is number of ways to triangle polygons. This one. Finally, this is some of the use cases actually. Then let's go with the formula. So we need to know the formula. Either we can just go with this one, or we can make use of the binomial coefficients as well. So if we directly go with the formula, so this one will be C0 equals 1, and we can just go with Cn plus 1 equals Ci into Cn minus I for I equals 0 to n. So this is kind of formula. You can just remember this one, right? So or don't mug up. So just this one, save it somewhere. So if you want to implement somewhere, this one will be helpful actually. Yeah. So this is fine. Or we can just make use of the binomial coefficients as well. If you are making use of the binomial coefficients, so it will be Cn equals 1 by n plus 1 into 2n choose n, 2n choose n, right? So this is fine, I believe. So this is it for the Bell numbers and the Catalan numbers. Now, let's do one thing. Let's start writing the algo. Let's start writing the algorithm. Let's first let's go with this one, Bell number function, right? So this is just the function to compute or the calculate Bell numbers using the Bell triangle. So let's make use of the Bell triangle, right? So we'll do one thing. So we'll be making use of the dynamic programming one. Yeah. So I'll just go with F here. Bell number, all we need is the parameter n here as discussed. So this is fine. So now first let me initialize Bell. So here this one actually 0 for I in the range, for 0 in I in the range actually n plus 1. This is fine. N plus 1 for this one, j in range. So this one will be n plus 1 as well, n plus 1 as well, right? So this will be Bell of 0 0. The base case, let me assign this one to the 1, right? So this is fine. Next, let's move on with the for loop one. So this one will be for I in range, for I in range 1 comma n plus 1. This is fine. 1 comma n plus 1. We are considering for the each row, right? So let's go with the first value in the row. So this one will be Bell of I 0. That is equivalent to the Bell of I minus 1 into this one, I minus 1 itself. I minus 1 into I minus 1. Let's go with this one, j actually. Let's fill the remaining values for j in range, for j in range. So this one, 1 comma I plus 1. So this is fine. Yep. Now let me assign Bell of ij, or this is in the terms dp of ij usually we go with, right? So we are just considering Bell of ij, the keyword Bell we are considering instead of dp, this one dp. Yeah, usually we consider here dp instead of this one. We are, as this is completely related to the Bell number, this one we are considering the keyword this one Bell. This is fine. So we will be going with the Bell of I minus 1 into what we discussed. Actually, it's j minus 1, I believe, right? The explanation. Yeah, I think so. So I'll just go with Bell of this one, I into j minus 1. Yep. So finally, what we need to return? We need to return Bell of n 0, right? So we need to return Bell of n followed by the 0. Yep. So n0, so this is the first element in the nth row that is equivalent to the Bell number. So we need the Bell number itself, right? So this is fine. We are done with the Bell number algo, right? So this is fine. Next, let's write the function to compute or calculate the Catalan numbers using the dynamic programming, right? So I'll just go with def here, Catalan numbers of this one, Catalan number of n, the only parameter that we need here is n. So let me assign, or let me initialize Catalan, variable Catalan, to this one 0 into n plus 1, right? So this is fine. Now let me go with the Catalan of 0. So this one of 0 equals to 1. So this is fine. Next one, let me go with for I in range, for I in range. So this one will be 1 comma n plus 1, 1 comma n plus 1. So this is fine. Also let me go with a for a j in range, for j in range of I. So this is fine. Then what we will do, let's go with the Catalan, this one, Catalan of I equals Catalan of I plus, so Catalan of j, Catalan of j into, let me go with Catalan of I minus j minus 1, I minus j minus 1, right? So this is it for the algo. Basically, all we have to do is we have to return the this one, nth Catalan number. So this one, I'll just go with the return made use of the keyword Catalan of, let me pass n here. So this is fine. So this is it for the algo, right? So we have successfully written the bell number and the Catalan numbers algorithm successfully using the DP, right? So let's consider simple example here when n equals 5. So let me print for the bell number. I'll just go with the bell number for n equals let me go with here comma n comma, so this one I'll just write it over here like this is mm, let me go with, let me call the bill number function here, so this one of n. Yep, so this is fine. Also let me print here instead of the bell, let me give Catalan number n equals the same thing ns. So instead of the bill number, let me call the Catalan number here. So this one let me remove and let me go with the Catalan number. Let me call the Catalan number function here, right? Of we have to pass the n itself. This is fine. So yeah, we have the idea on the algorithm completely. We have discussed this one step by step. So accordingly with the example that we have considered, what is the output that we need to get here? So just give me a second here. In this case, so we are considering n equals 5, right? So the bill number for n equals 5 bill number. So this one we are considering. So first print statement and second print statement. For the first print statement, the bill number for n equals 5 has to be or is accordingly with what we considered, what we have written in this thing, it has to be 52, right? So why it has to be 52? See, all 52 ways I cannot show you. There are 52 different ways to partition a set of 5 elements into non-empty subsets, right? So there are 52 different ways to partition a set of 5 elements into the non-empty subset. So we have considered here n equals 5, meaning set of 5 elements. So there are 52 different ways to partition a set of 5 elements into the non-empty subset. So the output that we need to get here is 52. And next we are considering Catalan numbers. Catalan number n equals 5 itself we are considering, right? N equals 5. So this one is, it has to be 42. What does the Catalan numbers do actually? So basically we have to go, or we have to find the valid combinations of the this one balanced parenthesis or the binary tree structure, right? So we are going with the 5 pairs or nodes here. So we have considered again same thing, 5 pairs or 5 nodes actually, right? So this can be considered as 5 pairs or 5 nodes. So total there are 42 valid combination, this one 42 valid combinations of balanced parenthesis or binary tree structures with the 5 pairs or nodes here. So this one I cannot show you the for all 42 this one, what we call valid combinations. For this also I cannot show you all the 52 this one, different ways to partition this one, a set of 5 elements. So I have just shown you the output directly, right? So for this example bell number we have already considered, this one we have already discussed. We have the idea how we get the 52 and 42, right? So we have considered this one. I have explained you algorithm step by step, what we are finding, what we are going to do, right? How we get the this one 52 and 42, why we get the 52 and 42, these kind of things. Yeah, we know it already. Now this is the output that we need to get. Yeah, so let me come here, let me do one thing, let me copy the entire this one file, just give control J, clear screen. So I'll just go with the Python followed by the this one file number.py. So let me hit the enter button. See here, we have bill number for n equals 5 is 52, right? So Catalan number for n equals 5, we are getting 0. Somewhere we have done something wrong, man. So this one, why it has become plus plus here? Catalan number of I, this is equivalent to Catalan number of I plus we are going with. So that is the reason we were getting wrong answer, I believe. Let me run this one again. Yeah, now we are getting the correct output. So this was basically wrong. So bell number for n equals 5 is 52 and Catalan number for n equals 5 is 42. Yeah, we are getting the desired output as discussed. So whatever the algo that we have written works absolutely correct. Yeah, works flawlessly. This is fine, man. Now we are done with this algorithm. Yeah, Bellman numbers, sorry, bell numbers as well as the Catalan numbers. So we are done with this algorithm. Now let me summarize whatever we have learned so far. Just try to remember these things, man. Yeah. So bill number basically the formula is recurrence via Bell triangle, right? So this one, just give me a second here. Bell number. So basically recurrence via Bell triangle. So this one you can clearly see here, recurrence via Bell triangle. So for the Catalan number, the formula is Cn equals 1 by n plus 1 into 2n choose n into 2n choose n. Yeah, so that is the formula. Formula for the Catalan is Cn equals, so this is basically related to the combinator x, right? So this one will be n plus 1 into this one 2n choose n, 2n choose actually n. So this is fine. And so meaning here, so for the first one formula I said recurrence via Bell triangle, right? So that means number of ways to partition a set into subset. So this one Cn, so this is nothing but the formula for the Catalan number Cn, right? So this is nothing but the number of correct recursive structures, nothing but trees or the parentheses, right? So just remember these two things, right? So you have to remember these two things actually. So in short, if I want to tell you, Bell is related to the set partitions and Catalan, it's related to the recursive structure or the balanced forms in simple terms, right? Again, let me repeat this. Just listen to this. Bell, so let me write it over here. Bell is nothing but set partitions, right? So I'll just write set partitions here, set P. Catalan is nothing but the this one. What do we call recursive structures, right? So recursive structures. I'll just write here. Recursive structures or the balanced forms, nothing but I'll just write here balanced forms, right? So let me write completely balanced forms. Yeah, this is fine, I believe. Now we are done with the this one algorithm. We are done with the Bell and Catalan numbers algorithm. Yeah, next we will be discussing the this one 3DP algorithm, right? So for now, this is it. Thanks for watching, guys.